Okay, so I want to talk about the intermediate value theorem. And the way you usually see this theorem is in a question that would say something like, use the intermediate value theorem to show that the function f of x equals, making something up here, 2x to the third plus x plus, I'll make that minus, no, I'll have it plus 5 has a root on the interval from -1 to 2. Okay, so one thing about the intermediate value theorem is it shows existence. It doesn't tell you what it is. So to show that something has a root, what you do is, there's another way this question could have been asked. So this is one way it could have been asked. So let's say it could have been asked this way. It could also be asked this way. Use the intermediate value theorem to show that x plus 5 equals 2x cubed has a solution in the interval -1 to 2. Now we'll assume that the instructor is not lying to you and that it does in fact have a solution, although since I made this problem up, and I am terrible at that, it's always possible that it does not, but we'll find that out soon enough. So the first thing you have to say, and your words here are very important, so you have to state all of these things. So first you have to say, since f of x is continuous, and then you might or might not have to say, give the reason why it's continuous, and this one, because it's a polynomial, you might not have to say that. You might just say it's continuous. Since f of x is continuous on -1 to 2, and f of -1 equals -2 times -1 cubed plus -1 plus 5 equals -2 times -1 minus 1 plus 5 equals 2 minus 1 plus 5 equals 6, and f of 2 equals -2 times 2 cubed plus 2 plus 5 equals -2 times 8 plus 2 plus 5 equals -16 plus 7 equals -9, and -9 is less than 0 is less than 6. We're using 0 here because we're looking for a root. by the intermediate value theorem, there exists a C element, C in the interval -1 to 2, such that f of C equals 0. Therefore, and then depending on which way the problem was worded, ... has a solution in -1, 2, or has a root in -1, 2, and just depending on how the problem is worded. And another possibility would be a problem that looks like this. Show that for some value in the interval 1 to 6, f of x equals -2x to the third plus x squared. No, I don't want to get that big. Let me change that to -4, some value in the interval 1, 2, f of x takes on the value takes on the value -10. So we would say f of x is continuous, and then if you wanted to, you could say because it's a polynomial, if it is a polynomial, f of 1 equals -2 times 1 to the third plus 1 squared minus 4. It's -8 plus 1 is -7, minus 4 is -11. I did that wrong a minute ago. Yeah, I did that wrong. So hold on. I would change the problem. Takes on the value -13. So is this right? -2 plus 1 minus... Wait, where did I get -11 from? I cannot do arithmetic. That's -2 plus 1 minus 4 is -5. So we'll leave it at -2. But then we have f of 2 equals -2 times 2 to the third plus 2 squared minus 4 is -16 plus 4 minus 4 is -10. Okay, so we had f is continuous, and we have f of 1 equals -5. This is -16. I'm getting sleepy. F of 2 equals -16, and -5 is less than -10, or the other way around. -16 less than -10 is less than -5. Therefore, there is a value C in 1 to 2 such that f of C equals -10. So these are the things you have to say. You have to say that the function's continuous on the interval. this function is continuous everywhere, but you need to say it's continuous on the interval. You need to find the values at the endpoints. So you find these values. You need to say that your target value is in between those two endpoints. And once you've shown that, then you can state your conclusion. Therefore, there is a value C in the interval such that the value of that equals your target value.